Let us have some advanced applications of Newton's second law. An object with a mass of 0.2 kg was acted upon by three different forces. Forces F sub 1 and F sub 2 are directed along the x-axis, and they have magnitude of 4.0 newtons and 2.0 newtons respectively. F sub 3 is directed at an angle of 30 degrees and has magnitude of 1 newton. Each situation is illustrated by three diagrams below. What is the acceleration of the object in each situation? Let us analyze the problem. A single object with a mass of 0.2 kg was acted by three different forces with values of 4 newtons, 2 newtons, and 1 newton. Two of these forces, F sub 1 and F sub 2, lies in x-axis, while the third force is directed at an angle of 30 degrees. We have three free diagrams below the problem where the dot represents our object and the arrow is the force. In illustration 1, notice that only one horizontal force acts on the object. Therefore, we can compute this by our equation F is equal to ma. Let us add a subscript x after a to distinguish that the acceleration caused by this motion is in x-axis, and subscript 1 after f to identify it is force sub 1 we are dealing with. Once again, we are looking for the acceleration, so we derive this formula as A is equal to force over mass. With the given data, we can substitute these values now. F sub 1 is 4 newtons over 0.2 kg. Then, our final answer would be 20 meter per second square. Notice that the value is positive. That means the object accelerates at 20 meter per second square to the positive x-axis, which is going to right. We are done now with situation A. Let us have situation B. From this free diagram here, we say that there are two forces acting on the object. F sub 1 is going to the positive direction of x-axis, while F sub 2 is going to the negative direction. We will still use our derived formula, A is equals to F over m, but this time, we put the word net in subscript to remind us that we are looking for net force, or the total force acting on the object. We can further modify this to our working equation as A sub x equals to F sub 1 plus F sub 2 all over mass. Let us substitute the values. F sub 1 is equal to positive 4 newtons plus our F sub 2, which is negative 2 newtons. This is negative because it is found in the negative side of our x-axis. Therefore, our resultant force is positive 2 newtons over mass, which is 0.2 kilograms, and we will yield an acceleration of 10 meter per second square. Still, the object, after it is acted upon by two opposing forces, accelerates 10 meter per second square in the positive direction of the x-axis. We go now with our situation C. Two opposing forces are acting on our object, one in negative x-axis, our F sub 2, while the other one, F sub 3, is not directed along the direction of the object's acceleration because it is directed at an angle of 30 degrees. Just like what we did in our previous situation, we need to find the resultant forces before we can substitute this in our derived formula. A is equal to F over m. Since they are opposing forces, we can find the resultant force by algebraically adding them, F sub 3 plus F sub 2. Remember that F sub 3 is not in x-axis, so we need to find first the x component of this using the formula F sub 3 cosine theta. I have a separate video about getting the x and y components of vectors. You may want to visit that by clicking the link in the description. We substitute the values now. Our F sub 3 is 1 newton multiplied by cosine 30 degrees, which is our angle. Then their product will be added to negative 2 newtons. Our resultant vector will be negative 1.13 newton. Do not worry if it is negative. It only means that the greater force pulls to the negative direction of x-axis. over 0.2 kilogram, which is our mass. Our acceleration will be negative 5.7 meter per second squared. This means that the object is accelerating towards the negative direction of the x-axis. So, we have three accelerations now for each case. The first one is 20 meter per second square. The second one is 10 meter per second square, and the last is negative 5.7 meter per second square. I hope this is clear. I also uploaded some drills in our BBL, and feel free to practice applying these laws in problem. If you have questions, clarifications, or anything you are comfortable sharing with me or with your classmates, we can start a discussion or comment in this video or send me private course message. Again, this is Gilmar De Castro, and see you in the next video.